So now we're talking about our building our irrigation system. So we want to start figuring out how do we design a solution for that. And we are on page 22 of our science book. And it is entitled, How Can We Design a Solution? So you kind of met to talk about building a prototype. Now what we've realized is obviously we cannot meet in groups to design that prototype. So everyone is going to be designing and implementing their own irrigation system. And today we're going to be talking about how can we design a system. So let's start answering our questions, and our questions are going to help us through that process. I don't need anything there. So it says, in the last lesson you learned about the problem of the plants. And we're going to talk about that again right now. The problem of the plants needing water. What might a solution look like? And by the end of this lesson, you'll be able to consider constraints and criteria and brainstorm to design a solution to the problem. So that's what we want to do. We want to figure out how can we solve this problem of the plants. And so there will be some ideas in here that might help you figure out some ideas on how to water those plants. Okay, boys and girls? So let's look. Look on page 23. Put your eyes on page 23. It says, can you solve it? First off, remember from lesson 1, school will be locked for a 2-week period, for a 2-week break. No one will be able to come to water your class's indoor garden. So that means, boys and girls, will the teacher be able to come in and water the plants? No. Are the maintenance people going to water the plants? No. So no one can come in and water the plants at all. So that's the problem. No one can come in and water, so we have to figure out how can we water the plants. So we have to design a system to water the plants. And what do plants need, boys and girls? Plants need, look at the little circles, plants need light daily to survive. So plants need light. Plants need a certain amount of water too. So plants have to have water. They need light and water. 2 things plants need. So now let's look at question number 1. Who would like to read question number 1 for me? Olivia?
How can you make sure that the plants are watered in the breaks?
Okay. So how are we going to make sure that they are watered and healthy during the break? What are we going to do to make sure of that? What are we going to do to make sure that the plants are healthy and watered during the break? What are we going to do? Bryson?
Build a prototype.
What are we going to do?
Build a prototype.
We're going to build a what?
Prototype.
We're going to build a system, right? We're going to build a system to water the plants. So let's put that down as the first thing we're going to write. We're going to number 1. Now this is a multi-part question. So first we're going to start with, we will build a system I know you called it a prototype, right? We'll build a system to water the plants. Okay, so that answers question number 1. So we're going to build our system. read the second question there. Gabe, nice and loud.
What steps would you take to solve this problem?
Okay, so what are we gonna do to solve this problem? What do we have to do? Evelyn?
We have to try to keep the plants from getting dried out or survive.
Yeah, we have to try and keep the plants from getting dried out. And we have to use the materials, right? So we have to figure out a way to keep the plants from getting dried out. So we have to use our materials. We have to use our materials list and figure out a way to keep the plants from getting dried out. So we will use our materials. The materials list to, we'll say design, how about that? To design a system to water the plants. Okay, now we have our next question. We'd like to read the next question we have to answer. Bryson?
What are some of the
Constraints.
constraints?
So what are some of the constraints that we're facing right now with what we're doing that I talked about? What is the constraint that now we've just faced? What can't we do together, boys and girls? Lucas? Well, we can't water our plants, but what's the constraint we're working with in our classroom? We can't do what, Bianca? We can't work in groups, so that's one thing. We can't work in groups. So we'll say one of our constraints is we can't work in groups. We can't. Okay, so we can't work in groups. So that is a constraint. Can't work in groups. That's a constraint in our project and doing our experiment. Yes. Now, we have the last problem, or the last question we have to decide upon. Who would like to read our last question? Rose?
What are
Criteria. So, yes, what are the criteria? How will we know we've been successful Santiago? After 2 weeks, how will we know that our system worked? We want to water our plants. How will we know it worked? What do you think? What do we want the system to do? We want it to do what to our plants?
Water them.
Yes, water them. So if our watering system is successful, what will it have done? It'll have watered the plants. So the criteria will be met if our plants are watered and our plants are still alive. Yes. So we'll say the criteria will be met if the plants are watered and still alive. Because that's what we want. We still need our plants to be watered and still alive, because that's our goal. Now, when you're done with that, I want you to turn your page. So finish writing, and then we're going to see some different ways that water moves. Okay? Now, everybody be on page 24. Page 24. Turn to page 24. This is called water movers. Everybody be on water movers. And it says researching solutions. And this might help you with your irrigation system. And it says, think about a problem you have had. Did you ask others how they might solve it? Have you ever asked other people how to solve a problem? I know that I do. If I'm having a problem with something, maybe something here at school, some technology, I ask other people how to solve it. If people here at school are having problems with something, they might ask me how to solve it. Oh, and it says here, sometimes the best way to begin solving a new problem is to look at how others have solved similar problems. And that's something that the teachers do here at SJE. We'll say, oh, have you had this problem using this, and how do you solve it? And then we all pool our similar experiences to solve the problem. So, it says when grain is scarce. What do you think the word scarce means? What does scarce mean? Does anybody know what the word scarce means? Okay? Scarce means not a lot of. lot of something. Not a lot. So when rain is scarce or there's not a lot of water, people often use irrigation systems. Below are some of these watering systems. So an irrigation system is a watering system. That is a watering system. A way to get water. Boys and girls, who has an irrigation system in their lawn? That would be your sprinkler system pops out of the grass and waters your grass that way. Okay? That's an irrigation system. If the sprinkler heads pop out and water the grass, who just pulls their hose and then uses a sprinkler on the end of the hose to water their grass? That's an irrigation system as well. It's a watering system. Who doesn't water their grass? I like to almost never water my grass. I let Mother Nature water my grass. I let God water my grass. So I use Mother Nature or God as my watering system. Yes?
Actually, me and my mom and my dad, they got like sprinkler hoses.
Yes.
They're all like little dots and it, water comes out. That's what we usually use.
Nice.
Or, my mom like just lets it rain and.
Yeah, let it rain. Of course, we haven't had very much rain, so what color is most people's grass right now? Yes? Kind of what? I can't hear you. Somebody else tell me what color is everybody's grass? Ava?
Brownish yellowish.
Yeah, brownish yellowish from lack of rain for sure. Because it's been was the driest August in like a zillion years. Okay, so it says some irrigation systems. Look here. It says look at these irrigation systems. Circle the picture that probably uses the most water. So look at A. Watering canals carry water to farm fields. So that's a canal in the middle or down the center of the field. And that carries water. The plant's roots can get to the water that way. Then we have B. Sprinkler systems water large circular areas of farms. Who's ever seen that one? You can see it sometimes if you're driving down the road and you can see it in the farmer's fields, those circular ones, and then they sprinkle them. It's like a huge sprinkler, and the farmers use it to water. I've never seen the canal one, but that one would be hard to see. C, drip hoses. Let out tiny drips of water near the hose. Can you see the droplets of water on that one, boys and girls? The drip hoses. You can buy drip hoses at the store if you want to do drip hoses at your house. People will put them in their gardens. And then D, watering spikes. Seep water into dirt over a long time. So it's like, do you see the red bulb in there? So you fill the bulb with water, and then you poke it into the plant, and it gradually releases water into the roots of the plant. So which one of those do you think uses the most water? A, B, C, or D? Which one do you think uses the most water? Santiago?
B.
B, the sprinkler system. Everybody circle B. Circle B, because that uses the most water. Yes, Rose? What? Hurry. Okay. Go to number 3, please. Which irrigation system on the previous page might be the most practical solution to your problem? That would be watering the plants in school. Which of those two do you think we might be able to use in the classroom? 2 of them. A, B, C, or D. There's 2 of them that would probably work pretty good with our plants. What do you think? Bianca, which ones do you think would work? Which one?
D.
Did you say which one?
D.
D or B? D? D, yeah, D might work, so circle D. Olivia, which other one do you think would work?
Circles.
Drip hose, C, so circle C and D. Okay, number 4, we are not researching other ones. Okay, now I want you to turn your page. And I want us to consider the constraints and the criteria of those 4 irrigation systems. And so think about each of the irrigation systems you saw and those you researched. Which systems might work well to solve your problem? Which systems wouldn't work well? So we're thinking about those 4 and how they would work with the classroom garden. Okay? So enter yes or no for each watering system. And the first criteria is provides water. Does the watering canal provide water? Yes or no? Yes. So write yes for watering canal provides water. Write yes, the watering canal provides water. Yes. Does the sprinkler system provide water, everybody? Yes. So write yes. Does the drip hose provide water? Yes. How about the watering spike? Yes. Okay. So now we have to decide, are those easy to control the flow? Is it easy to control the flow, do you think, on a watering canal? What do we think? Can we control the flow on that? No. So let's write no. How about on the sprinkler system? Can we control the flow on that big sprinkler system thing, do we think? No. Can we control the flow on the drip hose? Yes. Is it easy to control flow on a watering spike? Yes. Okay. So, let's look at the constraints. Would the watering canal work for 2 weeks? Yes. How about a sprinkler system? Yes. A drip hose? Yes. Watering spike? Yes. That would work for 2 weeks. Those things work for a while, depending on the size of it. Yes, Gabe? I can't hear you. Yeah, you can use those watering spikes. Now, here's the one. We have to decide which of these are safe for the classroom. Would a watering canal be safe for the classroom? Could we have one of those watering canals in our classroom? No. A sprinkler system. Could we have the sprinkler system going in the classroom? No. Can you imagine the mess that would be? How about a drip hose? Could you have that drip hose going in the plants? Yes, you could have that drip hose. And how about a watering spike? Could you have the watering spike going in the plants? Yes. Okay. Now, let's look here for number 7. So now we got to think. How does researching other solutions help you solve a new problem? So when we're researching other solutions, how does it help us solve a new problem? How do you think that helps you with a new problem? What do you think? So we're looking at other solutions, and how does that help us figure out a new problem? What do you think, boys and girls? Well, boys and girls, it gives you a starting point. That's what it does. So when we look at other solutions, it gives us a starting point for our problem. So for number 7, we could say, looking at past solutions gives you, oh, I don't need a comma there. I don't know why I wrote that comma there. Gives you a starting place. To find solutions for your problem. And then why, yes? Place to find a solution for, looking at past solutions gives you a starting place. Oh, I wrote the word place twice, so you don't have to write that twice. And then, why should you always keep constraints and criteria in mind when solving a problem? So we know if the solution is doable. So we know if the solution is doable. Once you've written that, boys and girls, you can put your science book away and line up for recess.